Hi, I'm Hayuni. Okay, today I want to show you the methodology that we use to complete this laboratory module. At first, we must construct the circuit using PSIM simulation software. Okay, so this is the complete circuit of a squirrel cage induction motor. After the circuit was complete, we must set all the values at squirrel cage induction motor. Okay, this is of our squirrel cage induction machine. Then we must set all these parameter to different values. Okay, this is the values that we choose. And then for number of poles, we need to choose three different number, which is we choose 2, 4 and 6. And then at load resistance, we need to choose 6 different values. We choose 0.1, 1.2, 2, 3, 5 and 15. And then after all the connection was complete and all the parameter values are set, and then we need to simulate this circuit. We need to simulate this circuit using this run PSIM simulation. Okay, we click run PSIM simulation button, and then these properties will appear, and then we need to choose one parameter that we want to produce the output waveform. At first we choose torque, and then the other parameters that we need to that we need to choose after this is output current, speed, torque, VA voltage, VAR voltage, power factor, input current and output power. There are 9 parameters that we must to produce the output waveform to get the result, to get the value of that waveform. Okay, and then we click OK. Okay, after that this waveform will be appear after we click the top, and then we must to click at global max button. We click this button, and then this table will appear after we click this global max. And then we just take this reading and put this reading in the Excel. And then to get the other parameter value, we only just double click at this waveform, and then these properties will appear, and then we just need to choose we only need to choose the others parameter value, and then we click add, and then just okay, and then the others waveform will appear, and then we repeat the same step to get the global max value, and then paste these values to the Excel, and then repeat the same step to others parameter. And then for the other poles resistor value, we only just change at this load resistance, and then we only change at this squirrel cage induction machine, and then change the number of poles to the others poles, which is 4 and 6, and then repeat the same step until we get the others data values. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noshami binti Abdulatif. I will continue my part, which is the result of our we open in the lab, which is squirrel cage induction motor. From this result, we get the speed torque characteristic, torque slip characteristic, speed slip characteristic. For the result for speed torque characteristic, we know that in this graph speed versus torque in class A. For class A, we use the small value of resistance, which is 0.1, 1.2, 2, 3, 5, and 15. For pole, we use 2, 4, and 6 pole. The value of torque is higher until the value of resistance at 3 ohm and slightly decrease at 5 ohm until 15 ohm. If the value of pole is increased, the value of torque is also increased. In each have normal starting height, starting torque, high starting current, and low operating slip. They are useful. The load torque is low at start, so that full speed is achieved quickly, thus avoiding the problem of overheating while starting. For for sleep for speed versus sleep characteristic, from this result, the value of speed at pole 4 is higher than others pole. When the value of sleep is higher, then the value of speed is also higher. Sleep, which varies from 0 at synchronous speed and 1 when the rotor is stopped. Determine the motor torque. Since the short circuit rotor winding have small resistance, even a small slip induces a large current in the rotor and produces significant torque. For torque slip characteristic, from this result, the value of torque is increased until 2 ohm and decreased until 15 ohm. Over a motor's normal load range, the torque slope is approximately linear or proportional to slip because the value of rotor resistance divided by slip dominates torque in a linear manner. As load increase above rate load, stator and rotor leakage reactance factors gradually become more significant in relation to such that torque gradually curve towards breakdown torque. That's all from me. Thank you.